Yeah. Right. Okay. Right. Thank you very much for coming. Yeah. It's been very nice talking to you before the webinar. So today we'll be talking about one what is it? One feature in MikroTik OSPF, and then the feature name here is aggregate. Actually, the prefix aggregate. Okay. So this is what we will discuss. Introduction, review, OSPF, OSPF area, and then the aggregate, of course. Okay, introduction for those who are new. So we are GLC, Gadanitas Cakrawala. We are based in Bandung. And then we do training, IT consulting. We do MikroTik, Ubiquiti, Linux, and then do software development. One of our product is Redis Manager, and then we do regular event. My name is Achmad Mardiansyah. I'm based in Bandung as well. Oh, why the slide looks like this? Okay, I will fix it later. Yeah, I'm Linux user, MikroTik user, Cisco router, Cisco user, many users. Okay. Yeah, for details, if you have LinkedIn, then we can connect. Please connect through LinkedIn. Yeah. If you connect through Facebook, yes, I do have Facebook. And then I don't think it's still allowed by Facebook because I have so many friends, almost 5,000, and then Facebook got warning, give a warning for me. Past experience, yeah, most of the our experience are related to ISP, either build ISP, upgrade ISP, design ISP, develop application for ISP, and then set up Linux for ISP, so on and so forth. Okay, yeah, thank you for the introduction. Okay, we got a guest here, a participant here from Philippines. Yeah, yeah, thanks very much for coming. Yeah, so yeah, if you don't mind, then just introduce yourself, perhaps. uh, Yeah, okay. So while you are typing there, and then we can just continue. So we prerequisite. Yeah, we assume you already know TCP/IP, of course. Yeah, MikroTik, and then routing protocol. In this case, is the OSPF. So this topic is not for beginner. Yeah, at least you must have OSPF previously, OSPF experience previously. Yeah, so this is not for blank people who try to um, to use MikroTik OSPF, especially for aggregate. So you need to have experience with that in order to understand the content. Okay, so let's review. So we already know the okay, I think I need to fix many slides here. Okay, the slides will be available on Slideshare, so you don't have to worry. Yeah, so it started from OC layer. So each layer has its own function, and inside the layer there are lots of protocols, and then those protocol has different functions. Okay, so we the propose for this is we want to try we are trying to do to have a better communication, and then in order to do that, there are lots of things that we need to think about, like how the message is reliable, and then how the message is encoded. What about the encryption? What about the security? And then what about the flow control? So those kind of considerations are put into the protocol. So there are lots of protocols, and then every year there will be a new protocol, especially for layer 2. Long time ago we have modem Phi90, if you know, and then we have a GPON that has higher capability compared to many years ago. Okay, and then we have a encapsulation. The data is capsulated, and then as you see, the overhead is big. Okay, so what you type on your WhatsApp is hello, but actually it's not only hello that the computer sends. Yeah, there are overheads for communication. Okay, and then we are doing, we were discussing on layer 3, which is the network layer. And here we, at least we know the difference between router and routing. Okay, and then when we design network, usually we start from the physical topology, how the network devices connect to each other physically. And then based on that, we set up the logical topology. Okay, and then based on that logical topology, we develop the routing tables. And we use this routing table to forward packets if there is a package coming, and then the router will forward to its destination. This is one example. You should be able to answer the correct answer. Okay, we're not discussing that about that. But at least you get an idea about the basics of routing, how routing table works. Okay, so here in MikroTik, this is the place where routing decision happens. Okay, so because we are talking about the OSPF, and then the OSPF processing will be appear here. Okay, that's the routing decision. So the OSPF will accept prefix, and then will send prefix to other routers. So this is how routing works and administrative distance. So it works like a board on the street. Okay, that shows you where to go. Either you are going to here, to there, or to here. Okay, so yeah, that's the destination. And then if we put a table, this is called the destination. Okay, and then this one here is the gateway. Okay, and then here's the distance. Yeah. Okay, and then you can see we have the same destination here, but different distance. Okay, and then the things that we choose, of course, the entry that has lowest distance, which means this gateway. Okay, so this analogy is bring to the routing table here, where the first field is the destination, is the gateway, and then this field is for the what is it? The distance, yeah. And then if you do route print on MikroTik, so this is the destination address, this is the gateway, and then here's the distance. So same concept, similar concept. If I not say same, and then we can say it's similar. Okay, so this is administrative distance based on based on the vendor. Okay, and then yeah, when we talk about routing, there are two types of routing. Either it's static route, it means that you have to log into your router manually and then configure the routing table one by one, or alternatively, we can use dynamic routing. Okay, so this routing table here. So this is the routing table that is available on every router, including so every network device, including your phone, your laptop, your smart TV, your modem, your many things. They must have, because they are attached to the network, they must have a routing table. Yeah, if you are using Windows, of course, Windows has a routing table. You can do IP route print or IP route print, yeah, a route show. I mean, you can just Google it to display a routing table on Windows machine. Okay. Yeah, as I said, routing table is important to do routing. Yeah, of course. And then, yeah, we have a dynamic routing here. It means that every router runs software called routing protocol. Runs routing protocol like BGP, OSPF, or RIP, routing information protocol, yeah, which already real RIP, okay, rest in peace. So many networks do not use them anymore. Okay, so and then you need to know that routing is asymmetric, yeah. So if A to B, path from A to B is not similar from B to A, okay. So as you can see here, from the host on the left, outbound is a blue line, okay, and then the return path is the red line. Yeah. Okay, so let's talk about the OSPF. Yeah, so OSPF is dynamic routing protocols. It's a link state. Yeah, it's not like RIP or BGP with Dijkstra algorithm. Yeah, so is it similar to ISIS? Yes, it's similar. ISIS is using Dijkstra algorithm. Unfortunately, up to now, MicroTik doesn't support ISIS. Okay, perhaps well, in the future, perhaps they put ISIS as one of the protocol we can use. Okay, it has routing, hierarchical routing. So there must be a area called area 0, which is the backbone. And then we split that big backbone into smaller area. So that's what we usually do in our network. And then OSPF is classified as IGP. Yeah, so it means that all router must have a same AS number. And then this protocol 89, many organizations use it. And then considerations requires more processing and then more complex compared to RIP. Lots of options. Yeah, you need to know how it works. So next, how OSPF works. So find neighbor router, hello packet, and then use multicast address, either .5 or .6. Okay, .6 is for DR BDR. It means that you are using a broadcast. Okay, a network. I think we have discussed the network type several weeks ago. Yeah. For troubleshooting OSPF, yeah, in order to make your OSPF stable. Yeah, either they're using multicast, and then each router sends LSP or LSA, and then every router receives those LSA and then build their own topology based on those information. Okay. And then when we talk about internet, we talk about the AS number and then other network that forms the internet. Yeah, so for example, this is the AS number AS4, this AS2, 3, and 1. Okay, so we run IGP inside the AS. Okay, and one of the IGP, Inter-Router Gateway Protocol, is OSPF. Okay, let's talk about the OSPF area. So when you are, okay, before we do that, some OSPF terminology. So here, neighbor, adjacency, link, and area. Area is a collection of networks, not collection of routers. So this is quite important, okay? And then here we have OSPF router type, for example, here. Okay, so this is so this is our AS, okay, AS number, and then this is our ASBR, and then here's the area 0, okay, and then here we have area 1, this is area 3, okay, and then this is the area 2, okay. The router that connects more than one area is called ABR, or area border router, okay, this and this. Okay, actually all routers, all area should connect directly to area 0. So this is area 0, this is area 2. Area 2 must connect directly to area 0. Okay, but here area 3 is not. Yes, for this case, we need to set up like virtual links from here to here. Okay, so that's the purpose of virtual link. Okay, so in this topology, as we can see, we have lots of routers and then all of them are running OSPF. So we can say that, yeah, all of these routers are put in the area 0. Okay, so and then here's the internet. Okay, so it means that router 86 is the ASBR, area border router. Okay. And then, yeah, here's we have, yeah. So that was big. Okay, so usually we split the area, okay, into smaller area. So previously all of them are area 1, but now this prefix on this area will be classified, will be put into a specific area, which is area 11. Here's area 13, 15, 17, 19. So where is the area 0? Here on top. Okay. So ASBR, this is ASBR here. Okay. Must be connected to area 0. Yeah, because the area 0 is the area where you connect to the internet. And then because it's sometimes it's called backbone network, backbone area, sorry. And because it's called backbone, and then I think the analogy is similar to what the human has, like a backbone, yeah, backbone in your body. So it must have a strong infrastructure for a backbone. Okay, it's like redundancy. The speed must be higher, and then yeah. So those two things. Yeah, stability is good. The router at area 0 must have a higher capability for LSA calculation, yeah, compared to the router at the area, yeah, other area than area 0. Okay. So yeah, this is what we usually do. So we have a big OSPF network, and then uh, from that big area, we split the area into smaller area. Okay. And then yeah, so this is how we apply the aggregation. Yeah, the aggregation scenario. Okay, usually, yeah, every area has a prefix allocated. Okay, so this area 11 here has a prefix. So for example, this prefix, so we have a /22, meaning from 10.40 16. Oh, sorry, this is 16.0. Okay, so we have a dot here through this IP address. Okay, so in total, perhaps there are more than 1,000. Oh, I have a chat here. Okay, I have a question here. Is area 0 router must be a border router? Yeah, so BGP router usually located in the area 0. Separate and border router. No, usually border router, because it says border, right? Connected to others. But it is possible that IR also running IBGP, right? There is a possibility for that. Okay, so yeah, that's how it works. Okay, so usually every area, the way you design your area is by allocating prefix. Yeah, so every area usually has its own prefix. Okay, so for example, area 11 here has its own prefix. Okay, and then inside the area, that /22 prefix will be split it into smaller subnets like 24, 25, or even 32. Okay, and then the ABR will merge all the split prefix. So this is the ABR, right? So this is the ABR, and here. So we have two ABR that is serving area 11. Okay, so inside the area here, okay, we have /22. Sorry, we have /24, 25, 32. So those smaller prefix are available here. But when router 1, when the ABR talks to the other ABR, what they advertise is just advertise the aggregated prefix. Okay, so this is how you define. Okay, okay, and then what's the benefit? Yeah, So it has a smaller routing tables at the other routers in other areas. Okay. So we reduce LSA calculation in other areas because we already split the area. Okay. And then smaller routing table means it's easier to debug when you display not so many things there. Yeah. It's very useful. Yeah. For PPP networks like PPP, PPPoE, LTTP. Yeah. So that because especially for PPPoE, sometimes the network is very dynamic. People are just come and go. So whenever there is a change in the interface, because PPP networks, the way it connects is by creating a new interface, right? A virtual interface. Every PPPoE authentication will create a virtual interface. So that's why when the interface is up, and then OSPF, the MikroTik will see IP addresses on those interface, and then if the interface is part of OSPF network, it will announce directly. Okay, so that's what happened. Yeah, so this is how you define the aggregate. And this is what happened before and after you apply aggregate. Okay, so before the aggregate, so this is what happened in other routers. Okay, so one way to verify your aggregation is by checking other routers. Okay, you log into other routers and then see whether the aggregation has been applied or not. Okay. So for example, in our previous example, we have what is it? /22, okay, /22. But inside the /22, actually there are lots of things here. Okay, so especially for /22, 32, like for PPP, and then we have others /28 also in that area. Okay, and then in total, if you can see, we have 400 items from that area for all routing tables, sorry. And then most of them are coming from that area. Okay, so after we apply, okay, and then here's what happened. Okay, so from 400, we only received 32 items, and then all items will be grouped into this prefix, yeah, 10.40.16.0.0/22. Okay, so here it is. Yeah, so as you can see, this is one way for tuning your OSPF network. Yeah, you can avoid the OSPF network by um, hiding the nitty-gritty details of these sub-prefix. Okay, and then I think what else? Yeah, I think that's all. Yeah, Q&A. If you have any questions, just you can type here or you can grab a mic to say something. If you're interested, just come to our trainings. Yeah, training is arranged in thematic and logical way. We have for MTCRE, every student will have, I think, more than 4 routers. Yeah, so we are using simulators for MTCRE. So yeah, it's designed to make you grasp the concept with hands-on experience. Okay, yeah, this is end of slide. Thank you very much for your attention. Yeah, feedback is available here. Okay, let me share in the group chat. Okay, and then further event will be available in our website. Okay, several we have been off several months in the past due to there are lots of projects going on, but we start the webinar again. Yeah, we have Facebook, we have slides. Slides will be available on Slideshare. Here's the link. Discord is from Bahasa Indonesia. Recording will be available on YouTube. Well, I think that's all. Anything else you want to ask? No? Everybody's clear? Oh, okay, I got the chat here. Oh, okay, just thank you. Right, yeah, I think that's all. Guys, hope you enjoyed the webinar. Hope you get something from the webinar here. Yeah, I would like to say thank you very much again. And then, yeah, see you in the next webinar. Thank you and have a nice day.
Thank you.